Hello guys, welcome to Lali Said we have, and for today we are going to learn about service area analysis, and that is network analysis in ArcGIS. So we are going to learn what this tool is and how important this tool could be. So what is service area analysis? So service area analysis is a geographic information system technique GIS used to assess the coverage and accessibility of service or facilities within a given area. It involves analyzing spatial data to examine and to determine the extent and quality of service that can be provided to to a specific region or population. So with all these plenty stuffs, in its simple terms, service area analysis is just a method that uses maps and data to figure out how service, how well services or facilities, that is, hospitals or stores, cover a certain area. So basically, you want to it will help you to understand where services are available, how far people might have to travel to get them, and if there are gaps where more services might be needed. So recently, I performed this kind of analysis for my thesis to determine the spatial distribution or the spatial pattern of healthcare facilities in a district. So basically, the tool was it took into consideration the road networks and also time travels. So then the analysis was performed to analyze the fastest possible routes an ambulance can um, navigate to a patient's house or to a hospital. It can also be used in fire or risk management analysis. So let's move further. So what are some of the key components of service area analysis? So some of the key points you can take from here is the service points or facilities. So it helps to identifying the locations of services or facilities such as hospitals, schools, retail stores, or other providing entities. And we also have the service areas. So this one is just defining a geographical area and that a particular service point or facility can effectively cover or serve. So let's say you have varieties of hospitals. You want to know um, how this service or facility can be effectively used to cover the entire district. So this could be based on factors such as the time travel, as we said earlier, the distance or other relevant criteria. And we also have the network analysis. So this one is also used to analyze tools to evaluate the connectivity and transportation infrastructure that can affect the accessibility of services. So it involves considering road network, public transportation routes, and other spatial data. So with the network analysis, you can use this analysis to perform the shortest possible route you can take to get to a service or a facility. And we also have the demographic or socioeconomic data that is basically aimed at integrating demographic and socioeconomic data to understand the characteristics of the population in the area. So with the thesis I wrote earlier, it was how hospitals in the or healthcare facilities could serve the entire population. So when you have the demographic data, you can use this tool to assess the demand for services and understanding the potential user base. So you have the optimization, that is applying optimization techniques to determine the most efficient allocation of resources or the best location for new facilities. So you also use this analysis to perform something like a feasibility studies to know where you can site a new facility or select some of the facilities that you deem to provide more efficiency. So this involves minimizing time travel, maximizing coverage, or optimizing the distribution of services. It is very, very good when you are using this. And lastly, it's used for creating maps and visual representation of the service areas to communicate findings effectively. So it is a very good tool, and I'll suggest it for businessmen, hospitals, what have you. So the service area analysis is applicable in various fields, including healthcare, retail, emergency services, and public administration. So, for example, in healthcare, it can be used to determine the accessibility of medical facilities for a given population, helping healthcare providers optimize their services and resources. So this was an extract of the thesis I wrote, and this were some of the findings I got from the tool. So what then is a network analysis? So the network analysis in GIS is basically the evaluation or the examination of interconnectedness of elements within a network. So basically, we are talking about interconnected elements within a network. So we have the nodes, the points, and the lines, and what have you. So this analysis is particularly useful in understanding the relationships, flow, and connectivity between various entities such as roads, utility lines, or social networks. So basically, I'm talking about connectivity and then flows. And then also to perform this in ArcMap, or to perform this analysis in ArcMap, the network analysis in ArcMap, the most important data you need is road network data and then your travel time. So these are the key data needed for performing network analysis in ArcMap. So in ArcMap, you can use it for routing, that is to determine the optimal path or route between two or more locations on a network, considering factors like the distance, time travel, or the impedance. So basically, um, you are having a healthcare facility. You want to use this tool to consider which distance could be cost effective to reduce your time, the distance, or certain barriers or obstacles. So there's also using assessing the geographic extent that can be covered within a specified distance or time. So it's very useful to understand the reach of services. They can also use it for network tracing. So this analysis was used during the time of the COVID era, that is, and the contact tracing. It was a very useful tool in doing that. And also you can use it to understand findings or downstream of elements from a specific point in a river network. And we have the location allocation. We have the traffic analysis used to study the flow of traffic on road network, including traffic congestion analysis and then route optimizations. So basically, in this tutorial for the practical, we are going to look at this four of them. Then in my next video, I'll get a data where we can practice this too. So in this video, you will be learning how to practice. We'll be learning how to perform the new route, the new service area, the new closest facility, and then the new location allocation. So basically, that's what you are going to be doing in this tutorial. So this was the example. So we have the 5 minutes drive. So with the roads here, you can when you have your road network, you're able to identify which roads can be accessible within 5 minutes to each of the facilities. So what you see in this blue are healthcare facilities, and then these are roads. So all these facilities, just 5 minutes drive from the facility. And then we have the location allocation rate, that is the service allocation rate for healthcare facilities. So with all these healthcare facilities, you're able to determine the most effective facility that can serve the entire community. So these ones are usually based on certain factors like the population of the area, the size of the facility, the road network, the travel distance, and then traffic congestions. It takes into consideration such factors. So let's move in to ArcMap. So I load my data. So these are the data I'm going to use. I'm going to use the ambulance service, hostel, food vendor, church, home, existing healthcare facilities, and then the most important one, of course, the road network, the district boundary. Yeah, so let's start with the network analysis. So as we stated earlier, the most important data you need for this is your road network. So we have our road network here. So like to open my attributes table, and then we have it's a line, of course, and that is what we are going to use. We are going to use the speed, the average speed of the roads. So as you can see here, some are 30, 0. These are the length of the roads, and then we also have the condition of the road. Are they good? Are they bad? Yes, so we are going to use these are the data needed to perform it. So mind you, in case you have your data but you do not have certain feature like the minute travel. So here, let me show you the minute travel. So we have the length, average speed, the surface, the country code, the name, then the shape length. This one is in terms of miles. So some of them have now figures. Then we have the minutes you can take to complete a road. All right. So sometimes you be having a data, so you be having just the length of the road, but you be lacking certain things like the minutes. So I'm going to briefly teach you how you can get the minutes in case you do not have the minutes, you only have the length of the road. So the first thing you need to do is to create a new field. So you know how to create a field. You come to the add field section, then you can basically so let's start with the length. So let's say we want the length of the road. Then you come to double, then okay. So as you can see, everything is here. And mind you, the length of the road we have here is in feet, and we want to convert it into miles. So to make it easier to work with, so we have here this one's are in feet. So we want to convert it to miles, so minutes per miles. So you right click on it, you go to calculate your geometry, you accept, then as you can see the length is here. Then you'll be asked to select one you want. So we want the mouse, then you can click on OK, yes, and it's going to calculate it based on the mouse for you. Then the next one you want to do is to add the minutes. So let's say you do not have the minutes of each of the roads, you just need to add the field. So minutes. Let me just do it M, then the double click on OK. So to find for the minutes, we are going to use the field calculator. Yes. So to find for the minutes, we need to um, do some bit of calculations over here. So we are going to need the length of the road in miles. So length of the road in miles divided by the average speed of the road, which we have here, multiplied by 60 seconds or 60 minutes in order to get the average minutes per travel on the road. So put it in bracket, multiply the asterisk by 60 minutes. Then we can click on OK, and you see it's going to, so the ones that are null are going to be null, and as you can see, these are some of the minutes per mile. So some are definitely going to be null. So if you have a complete data set, you're not going to get null figures. So this is how to calculate the minutes from the average distance, or sorry, the average speed and the length of the road. So once we got this, we can move straight to the network analysis. So the first thing you need to do is to come to your customize. You come to customize, then you come to extensions. So at extensions, usually people do not have it enabled, so you need to enable it here. So I've already enabled mine. So network analysis has been enabled. So once you do it, you can close it, and it's going to come like this. So let me take off this. So we have our network analysis here, and you can see we have the new route, service, new service area, new closest facility, vehicle routing problem, and then the location allocation. So this figures, or this these tools are not yet activated because we need to create a network data set. So we need to create a network data set. So to do that, you first need to open your shapefile where you have stored your road network file. So I have mine here. So I have my road network here. So you right click on it, and then you create a network data set. So it requires the network analysis extensions. So open it. You can rename it if you want. Next. So do you want to model things in this? So basically you can just leave it as it is. Connectivity has to be, and make sure it's ticked. Click on next. Can leave this ones. Next. Yeah, so this one we have, and we can decide either to use the length, the minutes, and also you can choose to add others if you want, based on the attribute you want or based on the cost you want. So the usage here, you can choose to use either the length as your usage or your cost, or you can use your minutes as your cost, or you can use, let's say, your population, the condition of the road as your cost element. So it doesn't really matter. Then when you're done, you can just click on next, and you can leave this ones. So you can choose to establish driving directions for this network, or you can choose not to, then you finish. Okay, so Sometimes the driving directions, the data needs to be geocoded. So if it doesn't work out, you need to go back. So could not create a network data set, so can just do away with it and then start all over again. So we create the network data set. Next, 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 next. So we can choose, sorry, a minute. Next, next. Then we don't want to establish our network data set, so no. Then finish. Okay, so we are not using the right data here. So this is the road network we are using. So let's export this. So we can name it as road merge. So road M, then okay. So it's already there, so we don't need it. So we have it somewhere. It should be somewhere here. So road M. So here we can create our network data set to very quick. So we want the minute. Next, next. So we don't want to activate driving directions. Next, then finish. So yes, so now we have created a network data set, and now you have to accept it, and then it's going to build a network data set for you, and you are going to have it here. So these ones are basically nodes. So these are the nodes. So the point you see here are just nodes. So they connect two or more lines. So nodes connect two or more lines. So we have it nicely built here. So now when we go back to our network analyst tool, we can see all the tools are activated. So once you build a network data set, the tools here are going to be activated. Yeah. So always make sure you use the right data. So make sure you save the road network you are using so you don't encounter challenges as we faced earlier. So also in case you cannot find your network analyst, you can just right click here and then you should check it here. So network analyst, and it's checked. So let's start with the new route. Yep. So with the new route, we have stops, the route, point barriers, restrictions, added costs, line barriers. So I'm going to explain what all these things mean. So the first one is our route. So let me uncheck this one to have a clear data. Okay, so we have from our map, we have ambulance service, that is the ambulance service. We have food vendor, and then we have the church, and then we have the hostel. So with the new route, we want to see, we want to make a route between let's say any of the services. So we want to make a route from your hostel to the food vendor and to the church. So we want to establish a route between these three locations. So let's see, with all the road networks here, which one would be the shortest possible route to use. So to do that, we need to come to the network analyst tool. So in case this doesn't open for you, in case you have something like this, you just need to open the window, the network analyst window, then you right click, then come to load locations, And then so the first one we want to do is from our home. Yep. So let's use the hotel rather. So we can just delete all. So from our hostel, so load location. So from our hostel, okay. As you can see, it has been selected as one, our hostel. Then that is our first location, our hostel. Let's add another one. So from our hostel to the food vendor. So from the hostel to the food vendor, and let's probably add another location to the food vendor and church. So let's add a church. Okay, so as you can see, the three locations have been established. So location one, location two, location three. Then when you are done, you can click on this window properties here to make some adjustments. So the accumulation attributes, do you want to use it in minutes or you want to use it in length? Either way, you can select it. Then analysis settings, you have to select the impedance, that is in minutes. You want it in minutes. Then I think everything here is okay. Then you click on apply, then okay. Then after doing it, you come to the solve, that is this button here, so to run the analysis for us. All right, so the analysis have been created for us. So we have the location. So with the network, let's zoom in. So with all this road facilities over here, if you want to move from this location to this location, this is the shortest possible route you can use, considering it in time. So the time is an important factor here. So if it could take you 5 minutes to get here, 10 minutes to get here, another 5 minutes to get here, making it a total of 20 minutes, probably it could take us an hour to move from here to here. So considering the average distance and then the average speed together with the minutes, it has been able to generate um, the shortest route for us. So when you perform this analysis, instead of using routes from here to here, when you use this analysis, you can just use from here all the way here, down here, down here, which you probably use let's say 10 minutes to get here. But if you should use a different route, let's say here to here, it will cost you about an hour. So this analysis helps you find the shortest possible route. So let's say at this location 2 here, there's a fire outbreak here, and then this is our ambulance. Using this analysis, the ambulance driver knows or the fire service knows the shortest possible route to get to the destination. So instead of navigating its way round with this analysis, it is able to use this um, route to get to the destination. And also sometimes when you turn on the direction, when you come to um, the find address, when you come to the find address, it's able to tell you turn left, turn right, just like how we see on our Google Maps. So here we didn't turn it on when we're creating our network and data set, so we'll not be able to have it here. All right, so we have the route here, as you can see. So when you should click on the direction, so you want the directions, you could see we didn't select the direction when we're creating our network data set, so we'll not be able to get the directions here. But if you should turn on the direction, it's going to tell you turn left, turn right at 100 meters, go for it, just like how the Google Map works. So this is basically how Google Map works. So this analysis is what helps it to work. So now you have a clue on how it works. Then we have the points barriers. So the points barriers are additional restrictions or additional obstacles you wish to add to your analysis. So let's say, so the points barriers could basically represent things like police checks, or let's say an accident. So those are barriers. Then you can add the restrictions just like the other ones we did, and then the cost. Then we also have line barriers. So line barriers could be like, let's say, a river, let's say a tree blocking the street, an earthquake where the road has been divided into two. Then we have the polygon barriers. So the polygon barriers could also be very huge obstacles. So these are very added information you would like to feeding into the analysis. So now you know how Google Map works. Now, just like how the ride hailing services work, like the Bolt, Yango, Uber, this is the service they run, and it's very, very efficient. Okay, so the next one we wish to perform. So we have it here. So the next one we wish to perform. So we can delete it. The next one we wish to perform is our new service area. So this creates a service area analysis layer. So just as you can read here, the service area solver generates polygons or lines that encompasses all edges within a given distance, travel time, or other impedance units from a facility. So let's see what we have here. So the service area, we also have it nicely here. So here you can also use polygon features or line features or facilities. So here too you come to the location. So we load our location. So here I probably want to use my existing healthcare facilities. Then I click on OK. So yeah, it's going to tell me there are 288 healthcare facilities. So 288 healthcare facilities. So with the service area, probably let's solve it and then see what it also has. So we come to the analysis settings. So probably want to use the default breaks. So let's say roads that can be accessed within 5 minutes, 10 minutes, 15 minutes, and then you can keep on adding and adding. So roads in this shape file, in this data set, that can be accessed towards or away from a facility within 5 minutes, 10 minutes, or 15 minutes. So you can see the direction. Would you want it away from the facility or towards the facility? The choice is all yours. And then U-turns at junction, you can allow, make everything yourself. Polygon generation. So usually you can use merge by the break value. So when the polygons overlap each other, they can just merge instead of sitting on each other like this. Then you can leave everything like this, the layer, everything, analysis settings, impedance, everything. Then you click on OK. Then when you're done, don't forget to solve it or run the analysis. So you run the analysis and it's going to solve it for you. So it's currently running. So we have to wait a little while. All right, so once the analysis has been run, it's going to give you the ones that are successful and then the ones that are not successful. So you can close it. And so we have it here. So we have our polygons. So the very dark ones, the dark ones are roads that can be accessed away from the facility, as we selected, away from the facility, from the road, from within 5 minutes. The very dark ones are the roads that can be accessed within 5 minutes. And then from 5 to 10 minutes, these are roads, the ones in the blue can also be accessed within 5 to 10 minutes. And then from 10 to 14 minutes, these are also roads that can be accessed within that period of time. So we have it here: 5 minutes, 10 minutes, and then more than 10 minutes. So you can basically change the properties to symbology, and we can, so let's try this. Okay. Okay. So with this analysis here, what it means is the green ones, the polygons that are shaded in green, away from the facility, they can be reached within 5 minutes. They can be reached within 5 minutes. And then the yellow ones, are basically, the yellow ones are not that much. So let's see. So these roads leading here can probably take you about 10 minutes to get to, can away from the facility. You can take, it will take you 10 minutes away from the facilities, and then this one here could also take you more than that, the 14 minutes. So this analysis helps you in making decisions. So probably for fire service, for ambulance, it is a very great tool you can use, whether you want to make the analysis towards the facility or the analysis away from the facility. So within, so if you have this hospital, all these routes here, all these roads here, it could take you 5 minutes to access all these roads. So from this facility to the road, it will take you 5 minutes. From this facility to the road, it will take you 5 minutes. But from this facility to this road we have here can probably take you 14 minutes and above. From this facility to this road here will take you 10 minutes. That is what the analysis is trying to. So as you can see, it's colored nicely, and you can add the point restrictions, the line barriers, the polygon barriers, just as we explained earlier. And the last one, let's do with um, the new closest facility. So the new closest facility probably can picture an incident like a fire outbreak, yeah, fire outbreak, or fire outbreak or an emergency service. So with this facility, with this analysis, you can, so let's check this one so you can have better data. So with this facility, we can input our locations. So let's say our facilities are, let's use, okay, so let's still use the existing healthcare facilities. So you have 200, and then the incident. So let's say our ambulance service. ambulance service. So just one, and we can add more incidents, and you come to the minutes. We want the minutes, analysis settings, time usage. So incident, so the travel from, so you can either use incident to facility or facility to the incident. So from the incident to the facility, or from the facility to the place of the incident. Then you can add more instructions, then okay, then you solve the analysis. Okay, so when it's able to do it, it's going to tell you the results, and when it's not able to, it's going to also tell you the results. So here we have just one route here. So one route, so you can see make maths collection. So let's see where that is. It's highlighted in green. So here, so an ambulance service, the closest ambulance service you can get is around this place. Yeah, so the closest ambulance service you can get is McMat Collections. I think that is a pharmacy. Yeah, so you can use this analysis to perform something like fire outbreak. So let's say we have our facilities to be our fire hydrants. So input your fire hydrant, and then our incidents where the fire is currently occurring. So I don't have data on that, but let me just give you that scenario. So you picture your facilities to be your fire hydrants. So let's say there are about 288 fire hydrants in the community, and then the incidents you have pinpointed where the firefighters are, or where the the firefighters, ambulance service, the incidents. You can input it inside, and then it will generate the shortest possible route the firefighters or the ambulance service can get to the various destinations. And once more, you can add the points barriers, other police checks on the road, traffic congestions, are there reverse speed ramps and others, are there very huge obstacles on the road. So this analysis is very, very good, and it can help you perform a whole lot of analysis either for transportation, business management, marketing, what have you. It's used in every field. And as we just discovered, this is analysis that helps run the Google Maps you use, especially for the ride hailing service like the Bolt, Yango, and the others. So guys, in my next video we'll be learning more like the new location allocation, like something like this one. This is an example of a new location allocation where the service area. So here the service area analysis facility allocation were executed using the GIS techniques. So the network analysis to define the areas within 5 minutes drive time. So from 213 facilities, 100 were selected based on factors like the population density, healthcare coverage, and disparity mitigations. So this analysis helps you perform this too helps you perform this kind of analysis, and it's very good. So as you could see here, based on um, the facilities we have here. Okay, I think I've lost that. So let me just bring it back to its normal size. So based on the facilities we have here, so all these are healthcare facilities. but this facility was selected as the most appropriate or efficient facility based on the um, population density, the time travel, and everything. So this facility was selected as the most efficient facility. So if you are a planner or a policymaker, you would want to expand this facility because the population over here is probably about, let's say, 1,000, whereas this ones could be over 100. So if you maximize or put more resources into this facility, its likelihood of serving the entire community is very, very high. So that is basically what the service area allocation does. So let me show you a few works on this. So with the GIS2, you can be able to perform the feasibility studies. So with the feasibility studies, you'll be able to assess where you want to site a new hospital, just like it is here. You'll be able to cite a new hospital or areas where you think a new hospital should be located. So guys, thank you so much for watching this exciting and educative video. I hope you do enjoy it. Feel free to share your thoughts, your comments in the comment section box below. I'm going to make the slides and the data available in the description box so you can explore and then interact with the data yourself. Please subscribe and watch out for my upcoming video that is titled Climate Chronicles episode 2. It's going to be exciting. Until then, bye bye.